In this video, we're going to take a look at some methods that we can analytically solve some limits at infinity. So here we have this theorem that we are going to use, right? So if r is a positive rational number, right, so it's a fraction, or so something that can be written as a fraction, a positive number that can be written as a fraction, and c is any real number, then the limit as x goes to infinity of c over x raised to the r, that is equal to 0. Right? So if you have some number over some variable raised to a positive rational power, then that limit is going to be 0. Furthermore, so if x to the r is defined when x is less than 0, then the limit as x goes towards negative infinity of that same thing is also 0. So let's look at an example. So here we have the limit as x goes to infinity of 3 plus 6 over x cubed. So if we're going to evaluate that limit, we could split that limit up into limit as x approaches infinity of 3 plus the limit as x approaches infinity of 6 over x cubed. For the first part, this part is just heading towards 3. The x value is not changing. For the other part, we are using this idea right up here. Right? So we have a constant over x raised to some power, some positive power. So the idea is as x gets really big, this number down here also is getting really big. 6 divided by some ginormous number is going to get really close to 0. And as that number on bottom gets larger and larger, we're going to get closer and closer to 0. So we get 3 as an output. Great. So let's look at some more examples where we're going to evaluate these. Here we have a limit as x goes to infinity of 3x squared minus 1 over 6x squared plus 2x minus 5. So to evaluate this, what we could do is we can factor out an x squared from both the top and the bottom. Why did I choose x squared? Well, I chose x squared because that was the largest power that showed up in the numerator. So I'll go ahead and factor that out. X squared, 3 minus 1 over x squared. And if we factor an x squared out of the denominator, we will have 6 plus 2 over x minus 5 over x squared. Here we can observe that the x squared on top then cancels with that x squared on bottom. And now if we use the theorem from our previous page, this top part, we have that value is going to head towards 3 minus 0 over 6 plus 0 minus 0. And so this term is heading towards 0. This term is heading towards 0 as x gets really big. This term is heading towards 0 as x gets really big. And so we're left with 3 over 6, or 1/2. So we can factor out that x squared, and that is a perfectly valid way to do that. On the next one, another way you could think about this, so here we have 2 over x cubed minus x. On this, you could think about, instead of factoring out x squared, we can factor out an x cubed from both the top and the bottom. So if we factor out an x cubed from the top, which is a little bit strange to think about because there's not an x cubed to begin with, that top will become 2 over x cubed. The bottom will become 1 minus 1 over x squared. The x cubed terms cancel, And the stuff on top, we will get 0 over 1 minus 0, which is 0 over 1, which is 0. So we can evaluate our limit there as well. This third one, this one I think is the trickiest. It involves a square root. And so we might be tempted to, so here we have the limit as x goes to negative infinity of the square root of x squared plus 1 over 3x minus 2. So we might be tempted to say, oh, I'm going to factor out an x squared. And that's really close to right, except for this is under a square root. So instead of factoring out an x squared, what we're really factoring out is a square root of x squared. And so if we factor out the square root of x squared, we have 1 plus 1 over x squared left underneath that square root. And then on bottom, we have a 3 minus 2 over x. So that's what we have there when we are factoring that out. So this now looks like x times 1 plus 1 over x squared over x. Oh, I lost my limit notation. Should still have a limit until we evaluate it. Over 3 minus 2 over x. The values of x, those cancel. And if we do that substitution, we will get the square root of 1 plus 0 over 3 minus 0, which gives us 1/3. And so we get 1/3 as our value there. And that is almost correct, except for it's not correct. What? I thought we did everything fine. So what is wrong with this? Well, the problem is when we factored out the square root of x, and we now just write this as x itself, because that x value is heading towards negative infinity, up here that top term is always going to be positive. But down here, as our x value gets really close to negative infinity, that bottom term is going to be negative. So what we ultimately should end up with is negative 1/3. So when we factored this out, we should have actually picked up the absolute value of x. So this right here was an absolute value of x, which is actually heading towards negative infinity as our x value, or is a negative x when our x value is heading towards negative infinity. So we should get negative 1/3 as our answer there. All right. Come back for our next video and we'll look at limits of trig functions. We will see you there.